Hey guys, today we're looking at 7.1 and 7.2, which is going to talk about the oblique triangles and law of sines, and then we're also going to talk about a very unique case of oblique triangles. So first of all, let's talk about what an oblique triangle is. It's actually the second box right here. An oblique triangle is any triangle that's not a right triangle. So we've been working a lot this semester in this class with right triangles and using SOHCAHTOA with right triangles and using our Pythagorean theorem, a squared plus b squared equals c squared with our right triangles. And so what we're going to talk about today and in our next video, our next set of notes, is the law of sines and the law of cosines, which is going to help us solve oblique triangles, which is any triangle that's not a right triangle. So the measure of the three sides and the three angles of a triangle can be found if you know at least one side and any of the other two measures. So you do have to know at least one side, but then you can know another side and an angle, or all three sides, or you can know two angles with that one side. But you just have to know at least one side and then two other things. So three things total. One of them does have to be a side. So at least one side and then any two other measures. So one side and two other measures. And so when we're talking about working with our oblique triangles, we can use our law of sines and our law of cosines to help us. Today we're going to talk about the law of sines. And then when we're looking at our law of sines, this works for very specific cases of our oblique triangles, and that's what our first box is. So I know that you might have seen that first box and you might have been like, oh no, we're going back to geometry and we talked about proofs and I hated proofs and it was terrible, but we're not doing proofs. We're just talking about the different options of how our triangle is presented to us. So our triangle could be presented to us with a side angle side, where we're given a side, the angle in between it, and then the other side, because remember we need to know three things. You could have angle side angle, where we're given an angle, the side, and then the other angle, so that side is in between two angles, or we're given all three sides. So if it's one of those three cases, we can use our law of sines. And remember, we've got to know three things, right? So if we're looking at example one, right here, it says use the law of sines to find C. So if you look, we're given an angle right here, an angle right here, and a side right here. So that's actually angle, angle, side, which was not one of those three mentioned up there, but is another option that we can use as well. I just didn't have enough space to fit it on the page, which is why I put it as one of our examples, so I can remind you that you could also use angle, angle, side, because if I know angle, angle, side, I could get it to one of those three options because I can find the other angle and then it becomes angle, side, angle, which is this middle one right here. So I could very, very, very easily figure out what this angle C is by just remembering that all the angles in a triangle add up to 180 degrees. So I'm going to do 180 degrees minus that 32 degrees for angle A minus my 81.8 degrees for angle B. And when I subtract all of that, I use my calculator to help me, and I get, let's see, 180 minus 32 minus 81.8 gets me 66.2 degrees. And now I've got my angle, side, angle. So now I can use my law of cosines, and that is what's in this box right here. Or sorry, my law of sines. That's what's in this box right here. My law of sines says that if I have side A over the sine of angle A, that's going to equal side B over the sine of angle B. And that's also going to equal side C over the sine of angle C. So you can set up any of these two ratios together to help me solve any part of my triangle. So I could just take these first two, or I could just take these last two, or I could take the A and C part and set those equal to each other as well. So I can set up this ratio and use it to solve for whatever part I'm trying to find. In this case, I am trying to find this B. This lowercase c right here is the side. So all the lowercase letters are the sides. The uppercase letters are our angles. So I'm trying to find this side right here, which means I'm going to use that angle. And then I need to figure out which other side and angle I know to help me set up my ratio. We do have a caution box over here. It says whenever possible, use the given values in solving the triangles rather than values obtained in intermediate steps. So if you look, I was given this side over here, which is side A, because it's across from my angle A. So I'm going to use that angle and that side to help me solve for my missing side C that I'm trying to find. Now, we are using that angle C that we did have to find, but to use our law of sines here, we do need that angle C to help us find side C. So it does say whenever possible, use the given values, but here it's not possible for us to only use given values. So I'm going to set up my ratio as A over the sine of A has to equal C over the sine of C. So side A is that 42.9 centimeters over the sine of angle A, which is 32.0 degrees. And it's going to equal, side C is what I'm trying to find, so I'm just going to leave it as that C. And then the sine of angle C is that 66.2 degrees that we just found. If I have this equation right here, I'm trying to get C by itself, so I'm going to multiply both sides by that sine of 66.2 degrees to get it out of that denominator, and that also gets C by itself for me. So this right here, I'm just going to plug into my calculator. When I do plug it into my calculator, I need to make sure that I'm in degree mode because we are working in degrees with all those degree signs. And when I plug all of that into my calculator, that will give me my answer. So check your mode, make sure you're in degree mode, and plug it in. Let me pull up my calculator here so I can kind of show you what it's going to look like. Split my screen. Okay, so mode. Oop, I'm in radians, so I got to change that. I'm going to type in sine of 66.2, close my parentheses, times, I'm going to do my fraction, 42.9 over the sine of 32.0 degrees, close those parentheses, and there's my answer. Let's round to 4 decimal places. So I'm going to say 74.0712, and it is a side length, so our side lengths are in centimeters right there. So 74.0712 centimeters is my answer for that side length. Okay, let's look at another example. I'm gonna leave my calculator up because we're probably going to use it for pretty much every problem for the first section of the notes. It says an engineer wishes to measure the distance across a river. He determines that angle C is 112.90 degrees, angle A is 31.10 degrees, and side B is 347.6 feet. Find the distance A across the river. So I'm trying to find this distance right here, distance A, which means I need angle A, which I have. So we're good there. I can set up that ratio of A over the sine of angle A. But I need to figure out what it's going to equal. And remember, I've got to think about what I've been given here. If I'm looking at this, I've been given side B, and I have not been given side C. But I've been given angle C, and I haven't been given side C. But I also haven't been given angle B, and so I've got to figure out which one is going to be easier to find. Now, if I have two angles, it's really easy to find the third angle in a triangle because they all add up to 180. If I've only been given two sides and it's not a right triangle, it's really hard to find that missing side. So the easier one to do here is figure out what that angle B is. So I'm going to do 180 degrees minus 112.90 degrees minus my 31.10 degrees to figure out what my angle B is. Okay, remember, this is not a right triangle, so you cannot use the Pythagorean theorem to just find that missing side. Cannot do that. Also, we only have one side, so really using the Pythagorean theorem wouldn't be helpful because you need to know at least two sides there. But just remember, not a right triangle, cannot use the Pythagorean theorem. Okay, so 180 minus 180 minus 112.90 minus 31.10 gives me 36. That's a nice, pretty number. So angle B right here is 36 degrees. So I can set up side B over the sine of angle B. So I'm going to plug all of that in. Side A is what I'm trying to find, so I'm going to leave that as A. Over the sine of angle A is the 31.1. It's going to equal, side B is 347.6 over the sine of angle B, which is that 36 degrees we just found. Okay, I need to get A by itself, so I'm going to do what I did in the last problem and multiply that sine over to the other side. And when I do that, that gets that A by itself. And then that gets me something I can plug into my calculator. Once again, we are dealing with degrees. So I need to make sure I'm in degree mode. We're already in degree mode, so we're good. And I'm gonna plug all that in. So I've got my fraction, 347.6 over the sine of 36. And I'm gonna multiply that by the sine of 31.1. There we go. Okay, that gets me that A is 305.463 what is it? Feet. Okay, and when you're looking at your assignment, it'll tell you specifically what to round to, and your test will also tell you specifically what to round to. But for today's notes, let's stick with our 4 decimal places. So that's how you can use your law of sines to help you find missing parts of the triangle. Now for both of these, we were just finding one missing side. However, you may have to find both of the missing sides or a missing angle or something like that. So just make sure you're paying attention to what it's asking you to find. Okay. Now you can also find the area of a triangle even if it's not a right triangle using sine. So that's the area formula that we have right here. It's the same formula. I've just written it out 3 times based off of what sides and what angle you know. So this first one right here, I know sides B and C and then angle A. Then it switches up over here. I know sides A and B and then angle C. And then it switches over here. I know sides A and C, but then angle B. So it's the same thing. You know 2 sides and then the one angle that doesn't match with those sides. But it's the same thing, just repeated 3 different ways. So for these triangles, we are going to go through and find the area of the triangle using this formula. So it's 1/2 times a side length times another side length times the sine of whatever the other angle is that would be in between those 2 sides. So right here, if I'm looking, I can label these sides to make it a little bit easier. Remember, across from angle A would be side A. Across from angle C down here would be side C. And then we have angle B. So that means that I would be looking at this one over here that's got side A, side C, and then angle B. So I would say that the area is equal to 1/2. Well, my side A was that 34.0. My side C was the 42.0. And then I would take the sine of angle B, which is 55 degrees, and 10 minutes. Okay, remember we talked about degrees, minutes, and seconds, like super early on in the semester. But also remember your calculator can do that for you. So when I plug all this in, I'm going to do 1/2 times 34.0 times my 42.0 and then times my sine. I'm going to do 55. Remember, you hit second apps 1 to get the degree sign, and then 10 second apps 2 to get the minutes sign. And you just plug it all into your calculator, and I get that my area is 586.0634. We are talking about area, so it's going to be feet squared. With an area, remember, is square feet. So there's my area. Okay, let's do the next one. If I'm looking here to find the area for the next one, remember we need two sides in an angle. I only have one side though. So I'm going to have to use my law of sines to find a missing side, and then I can find my area. So I'm going to come over here and I'm going to find side A. You also could find side C if you wanted to, because we know what angle C is over here. We know angle A and angle C, but I'm going to find side A just because, I don't know, A comes first in the alphabet. I don't really have a good reason for that. I'm going to find side A. When I'm looking at this, that means I'm going to have A over the sine of angle A. But when I'm trying to figure out what I need to set that equal to, well, the only side length that I have is side B. So it's going to have to be equal to B over the sine of B. But the problem is, I don't know what angle B is. There's a really easy way to find that though. Remember, all the angles just add up to 180, so I can subtract the two angles that I do know. So I'm going to do 180 degrees minus angle A is 24 degrees and 40 minutes, and angle C is 52 degrees and 40 minutes. So when I type that in, 180, I'm going to do second apps 1 to get the degree sign, minus 24 second apps 1 for the degree sign, and 40 second apps 2 for the minutes, minus 52 second apps 1 for degrees, and 40 second apps 2 for the minutes. Okay, that gives me this decimal. It's not a super great decimal because that 0.66666666667 repeating, that's a rounded number. That's not an exact value. So remember, if you hit second apps and then option 4 would convert it back to degrees, minutes, seconds, and you'll see that it's going to be 102 degrees in 40 minutes. And that is an exact value. So I'm going to use that instead of the decimal that has the repeating value, because that's more accurate. That is accurate, whereas the 0.67 would be a rounded number, and that might affect my answer a little bit. So remember, exact values is what we would like to use if we can. So that's my angle B, and now I can plug all of this in to find my missing side, so then I can find my area. So side A over the sine of angle A, which is the 24 degrees and 40 minutes. That's going to equal side B, which is the 27.3, over the sine of angle B, which we just found was 102 degrees and 40 minutes. A little longer. Okay, if I'm trying to get A by itself, I need to multiply both sides by that sine of 24 degrees and 40 minutes. So I'm going to multiply that over here. And that gets me A by itself and gets me something I can plug into my calculator. So I'm going to type in my fraction, 27.3 over the sine of 102, second apps 1 for the degree sign, 40, second apps 2, oh, that's not the right thing, second apps 2, 1, 40, second apps 2, times the sine of 24, second apps 1, and 40, second apps 2. Okay, and that gives me this decimal. Not necessarily the best decimal, right? So it is like 11.6775. Remember, we want to use exact values, so I'm just going to leave that in my calculator for right now, and I'm going to go through and find my area, and I'm going to use that when I go through and find my area. So when I am finding my area, let's do it in green. Remember, it's going to be 1/2, and I just found side A, and I have side B, so that's going to be A, B, which means I'm going to have the sine of angle C. So my area is going to be 1/2. I'm going to say A, and then B is 27.3 exactly, and then the sine of angle C is that 52 degrees and 40 minutes exactly. So what I'm going to do here to make sure I'm getting an exact answer is I'm going to do my 1/2, then I'm going to do times, and if you do second and then the negative sign, it pops up ANS, which stands for answer, and it's going to take that 11.6775446, that answer, and pull the exact answer. So you're not looking at the rounded number, it's the exact answer times that 27.3, and then I'm going to multiply it by the sine of the 52, second apps 1, and 40, second apps 2. And okay, so you should get an answer, and it should be about 126.7410 centimeters squared. Yep, there we go. And hopefully you're using an actual calculator instead of the app, so you don't have to worry about weird ads like I do. Okay. So that's kind of how you can use the law of sines. Now we're going to talk about the kind of weird, and it's called the ambiguous case. And so we talked about up here how you can use side, angle, side, angle, and side, side, but there is one specific case that you can't really just straight use the law of sines and solve for. And that's if you're given a triangle where it is side, side, angle. So if we're given two side lengths and then the angle that's opposite one of those side lengths, then there's a couple different possibilities for what could be happening here. So the easy way to remember that this one is the ambiguous case is because if you look at what I have highlighted there, if it's spelled backwards, it spells a bad word. So that's the bad one because it spells a bad word. And it's got this nice, lovely two tables that tell us the different options for what could be happening here. So if the angle that you're given, which we're going to say is angle A for our table, but remember it could be labeled differently based off of the problem you're looking at. If angle A is acute, you could have 0 triangles, 1 triangle, or 2 triangles. So you could have none, 1, or 2. And there's different things that cause this. So what you're kind of going to start by looking at is you're going to look at your two side lengths that you're given. So you've got angle A. Over here, you can look and see if A is less than B. Here, A is also less than B. And here, A is also less than B. This is our different one where A is greater than B. So this is the special case where A is greater than B. If that side A that matches with angle A is greater than the side B, then you're automatically going to have one triangle. Then the other thing that you want to look at is the sine of angle B that matches with that side B. So your first option is that if the sine of angle B is greater than 1, then there are no triangles. That's your 0 over here. If it is exactly 1, then you have one triangle. Then you've got two options down here where it is between 0 and 1. So when you're looking at that, you've got to decide, is the side length A greater than or equal to B, or is the side A less than B? And that's how you can tell if it's one triangle or if it's two triangles. So you're still going to use your law of sines here to help you. And once you figure out what that sine of B is, if it's greater than 1, if it's equals 1, or if it's between 0 and 1, that kind of helps you break down what your options are. Then this table down here, if your angle that you're given is an obtuse angle, you've only got two options. Makes it a little bit easier. You either have that your sine of B is greater than or equal to 1, which means there's no triangles, or you have that your sine is between 0 and 1, which means there's one triangle. So what we're going to do for the last part of this notes is we're going to look at a couple of examples, and we are going to figure out how many possible triangles there are. So we're not going to actually go through and solve the triangles. We're just going to figure out how many possible triangles there are. So let's get started. So example 5 says, how many possible solutions are there for triangle ABC given, oh, and like I said, you're not always given angle A. Here it says given angle B is 54 degrees and 40 minutes. Side B is 8.94 meters and side A is 25.1 meters. So it says in the ambiguous case, we're given two sides and an angle opposite one of the sides. For the sake of giving you the table, they said angle A, but remember, it's not always going to be angle A. So this one's, you got to think a little bit about it. If we're given side B, the side that matches up with that is the side B angle B, right? So when we're looking at that in our table right here, we were kind of talking about angle A. Is it acute or is it obtuse? Well, we're given angle B, so we got to figure out, is it acute or is it obtuse? So if we're looking, angle B is 54 degrees and 40 minutes, which is an acute angle, which means we're looking in that first table. So what I'm going to go through is I'm going to go and find the missing angle, the sine of the missing angle, and see if it falls into, is it greater than 1, is it equal to 1, or is it between 0 and 1? And then that's going to tell me 0, 1, or 2 triangles. So I'm going to set that up. You can see right here we've got B is going to go over the sine of B, and A is going to go over the sine of A. So side B is the 8.94, and then we've got the sine of angle B is the 54 degrees and 40 minutes. I don't know what sine of A is. That's what I'm trying to find. So I'm going to leave that denominator just as sine of A. But I do know that the side, the top of it, is 25.1. So here, I'm going to cross multiply. So that's going to give me 8.94 sine of A is equal to 25.1 sine of 54 degrees and 40 minutes. Then to get that sine of A by itself, I just need to divide by 8.94. So when I do that, that's the sine of A that I'm trying to get. It's by itself, and I can plug this into the calculator. So let me pull my calculator back up. Like I said, I told you we were going to use this for pretty much everything today. Okay, I'm gonna plug it all in. Got a fraction, 25.1 sine of 54 second apps 1, 40 second apps 2 over 8.94, and I get 2.29044. 2.29044, geez, is greater than or equal to 1. So if I come back up here and look at my table, the greater than or equal to 1 is this first row right here. Sine of b is greater than 1, which means there are 0 possible triangles. And actually, it's not greater than or equal to, it just needs to be greater than 1, which means 0 triangles. And that's it. We just needed to figure out how many possible triangles. There are 0 triangles. We're done. No triangles possible. Let's look at the next one. Example 6, how many possible solutions are there for triangle ABC given angle A? So back to angle A. So this one's going to match up a little bit nicer with our table. Angle A is 55.3 degrees. Side A is 22.8 and side B is 24.9. So if I'm looking at this, the angle matches up with that side A. Angle A, 55.3, is also an acute angle. So I'm going to go through and do my law of sines again and see if it's greater than 1, equals 1, or if it's less than 1. So I'm going to do A over the sine of A. And I've got B over there. And it's going to go over the sine of B. So 22.8 over the sine of 55.3 degrees is going to equal, side B is 24.9 over, I don't know what the sine of B is, that's what I'm trying to find. Once again, I'm going to cross multiply. So when I do that, it gets me 22.8 sine of B is equal to 24.9 sine of 55.3 degrees. I'm going to divide both sides by 22.8. And then I can plug that into my calculator. So 24.9 sine of 55.3 over 22.8, and I get 0.8978, which is less than 1. So when I look at my table, well, that is actually 2 different options. So that's where I've got to look at my A side length and my B side length and see which side length is shorter to help me figure out if it's 1 triangle or 2 triangles. So side A is 22.8, side B is 24.9, so A is less than B, which means it falls into this bottom one right here. There are 2 possible triangles. So that's all I have to say, 2 triangles. Hope if I had the pen. So once you do the law of sines, if it's one of those options where it's less than 1, then look at the 2 side lengths you were given and see if the side that matches up with the angle is smaller, then that means it's 2 triangles. If the side that matches up with the angle you were given is bigger, then it's 1 triangle. Okay, let's look at example 7. So doing it again, we're given angle A is 43.5. So that means that we have an acute angle. And let's go through and do our law of sines. So A over sine of A is equal to B over, sorry, C over sine of C. So A is 10.7 over the sine of 43.5 degrees, and C is 7.2 over the sine of C. So this one's not going to match up quite with our table because we have side B instead of B. So anywhere you see a B, just replace it with a C. Let's go ahead and cross multiply. I'm going to have 10.7 sine of C is equal to 7.2 sine of 43.5. And then I need to divide by that 10.7. So the sine of C is equal to 7.2 sine of 43.5. Oh, forgot my degree sign right there. There we go. Over 10.7. So 0.4632, which is less than 1 again. So that means once again, we're looking at one of these two options. So I need to see if, and remember we're replacing B with C, so I need to see if A is greater than or equal to B, so A is greater than or equal to C, or if A is less than B, or A is less than C. So if I come up here and look at this, the side A that I have is 10.7, and side C is 7.2. So A is greater than C, which means instead of my 2 triangle option, this time it's 1 triangle. It's that one case where I have the A is greater than or equal to B. So I've got 1 triangle. And last example, it says without using the law of sines, explain why A equaling 104 degrees, A being 26.8, and B being 31.3 meters cannot be valid for a triangle A, B, and C. Okay, so this one we're not actually going to use the law of sines because it says without using the law of sines, we have to explain this. So if I'm looking at this, the first thing that I'm going to notice is my angle being 104 degrees means I have an obtuse angle, which means this is the first time I'm looking at this bottom part. So I'm going to look at my obtuse angle, and it says don't use the law of sines, which means I need to look at my side lengths. So either A less than or equal to B or A greater than B is what I need to figure out. So my side A is 26.8 and my side B is 31.3. So A is less than B. So if A is less than B, that's how I know that there are no triangles. So I can come down here and make it just a little bit nicer. Let me get rid of the calculator. Since angle A is obtuse and side A is smaller than side B, there are no possible triangles. So there we go. So it's kind of easier when you're looking at obtuse angles. You don't have to use the law of sines. You could just say, okay, is this side bigger or smaller? And you can go from there. It's when you're looking at the acute angles where you really kind of need to look at your law of sines. So let me know if you have any questions. Get started on your assignment that goes with this, and y'all have a good day.